We'll talk in this lesson about artificial intelligence and the machine learning services in the cloud. So first, we're going to start off with artificial intelligence. Now, AI or artificial intelligence is a broad field of computer science that aims to create systems capable of performing tasks that would normally require human intelligence. Now, these tasks include problem solving, understanding natural language or perception, in other words, vision or speech recognition, and also decision making. Now, artificial intelligence has mainly 6 components. The first one is deep learning. Now, deep learning is a subset of machine learning that uses neural networks with many layers, and hence the name deep. So it's inspired by the structure and function of the brain, specifically the interconnections of neurons, and it could be applied with image and speech recognition, with medical diagnosis, and with financial fraud detection. Now, an example of deep learning is AlphaGo, which is developed by DeepMind. Now, AlphaGo used deep learning to defeat a world champion in the game of Go. Now, another component of AI is known as the natural language processing, or NLP. Now, this is a field of intersection of computer science, artificial intelligence, and linguistics. So it enables machines to understand, interpret, generate, and respond to human language in a valuable way. And it could be applied to chatbots, translation services, and sentiment analysis. And Grammarly is a nice example of natural language processing, as it uses NLP to analyze and correct text based on grammar, punctuation, and style. Now, the third component of AI is machine learning, and we're gonna see more of this. So machine learning is a method of data analysis that automates the building of analytical models. So it's a subset of AI that allows systems to learn from data, and it could be applied to recommendation systems, predictive analytics, and pattern recognition. Now, Netflix uses ML to analyze a user's watching history and suggest content they might like. Now, the next component of AI is computer vision, and this is a field of AI that trains machines to interpret and make decisions based on visual data like images and videos. And computer vision could be applied to facial recognition, to object detection, and augmented reality. Now, Tesla autopilot system uses computer vision to detect objects, lanes, and other vehicles on the road. Next, we have neural network, and these are algorithms designed to recognize patterns. So they interpret sensory data through a kind of machine perception, labeling, and clustering of raw input. And neural network could be applied to image recognition, to voice recognition, and prediction tasks. Now, Google's voice search uses neural networks to process spoken language. And then we've got cognitive computing. Now, cognitive computing is a system that mimics human decision-making processes and can solve problems without human intervention. And it could be applied to personal assistance, to data analysis, and to pattern recognitions. Now, IBM's Watson can analyze vast amounts of data to answer questions and assist in decision making. So while these are separate components of AI, they often overlap and work in tandem to achieve complex tasks. For instance, deep learning and neural networks are closely interlinked, where deep learning specifically uses large neural networks to analyze various factors of data. And similarly, NLP or natural language processing might rely on deep learning for better contextual understanding. And computer vision could utilize neural networks to identify objects or scenes in images. Now, let's move on to machine learning. And as I said, machine learning, or ML, is a subset of AI that focuses on the development of algorithms that enable computers to learn from and make predictions or decisions based on data. So instead of being explicitly programmed to perform a task, a machine learning system learns from data. Now, there are 3 types of machine learning: supervised learning, unsupervised learning and reinforcement learning. Now, supervised learning meaning the algorithm is trained on labeled data, meaning that the data is paired with the correct answer. Now, with unsupervised learning, the algorithm is trained on unlabeled data, detecting patterns and relationships in the data without any prior labeling. While with reinforcement learning, an agent learns how to behave in an environment by performing actions and receiving rewards or penalties. Now, in machine learning, there are 5 models and techniques. We've got classification models, and these predict discrete outputs, categorizing data into specific groups or classes. Now, it could be applied to email filtering, meaning that spam or not spam, or image recognition like a cat or a dog or a bird of images, or it could be applied to medical diagnosis. We also have the regression techniques, which predict continuous values based on input features, and it could be applied to stock price prediction, to real estate price estimation, and to predicting sales amounts. And then we've got clustering, and clustering is an unsupervised technique that groups data points based on their similarity without a predefined labeling, and it could be applied to customer segmentation, to grouping related news articles, and to anomaly detection. After that, you've got dimensionality reduction, and this is a technique to reduce the number of input variables in a data set while retaining most of the original information. So it's useful for visualization, to feature extraction, and to speeding up algorithms, and it could be applied to visualization of high dimensional data, to noise reduction, and to improving performance of other machine learning models. Next, we've got deep learning, which we already talked about, and deep learning again is a subset of machine learning models inspired by the structure of the human brain using artificial neural networks, and it is especially potent for large and complex data sets, and it could be applied to image and speech recognition, to natural language processing, and to game playing like AlphaGo, like we have seen just now. Now, these models and techniques often serve as building blocks, and they can be combined or modified to suit specific challenges. For example, a deep learning model like CNN might be used for image classification tasks, classifying images into predefined categories. And regression might be paired with dimensionality reduction techniques to improve predictive performance, especially when faced with the curse of dimensionality in high-dimensional datasets. And also, clustering can be applied before classification to uncover underlying patterns of or segmentations in the data, which can then be used to train more targeted classification models.